Hello, this is First Class Tyler Vito from Massachusetts Maritime Academy doing the Creature Feature project for Dr. Osborne's Tropical Marine Ecology class. This presentation will be on the buoy barnacle, also known as the Dosema fascicularis. Important background information on the buoy barnacle is that it's from the kingdom Animalia, phylum Arthropoda, subphylum Crustacea, class Maxillopoda, order Pendulicata, family Lepididae, and genus Dosema. Sorry for the pronunciation, I know they're incorrect. The buoy barnacle hangs underneath the water's surface connected to a float that is created by the barnacle itself, as you can see in the image to the right. This image also shows the reason why it is called the buoy barnacle, due to the fact it is very similar to a buoy. It travels by ocean currents and it ranges from North Siberia to the south of Cape Horn. However, it prefers warm and temperate waters in both the Atlantic and Pacific Oceans. The maximum head length of the buoy barnacle is 3 centimeters. However, the average head size of a buoy barnacle ranges between 1.2 and 2 centimeters. This image here shows the most extreme locations and spawnings of the buoy barnacle. As you can see, it goes all the way north up to the tip of England to the south parts of Australia. This image does not show the popular areas of the buoy barnacle, such as floating in between Hawaii, Japan, and the Philippines, among other tropical islands in both the Atlantic and Pacific Oceans. The buoy barnacle's float is made out of the same substance that connects it to the buoy barnacle, the concrete. It is the only barnacle that produces its own gas-filled float. It attaches to the float as a larvae, and multiple barnacles tend to attach to the same float, as seen in the second slide of this presentation. When they reach the older stages of their life, the cement tends to attach to other objects and organisms such as rocks, seaweeds, seagrasses, and sea turtles, for instance. The buoy barnacle is known to have high-strength concrete. This concrete is the same substance that used to create the float, as I stated earlier. This is because the concrete has a very porous texture. This porous texture allows it to be buoyant and stay at the water's surface. The buoy barnacle is known to produce the most amount of concrete out of any barnacle species known. Like other barnacle species, the buoy barnacle has a glands specifically used to create cement. After the cement is created, it goes through cement canals to attach to floats or other objects it wishes to connect to. Throughout the barnacle's life, the glands change. When they are in the younger stage of life, the barnacle's glands are small and circular, and they only create enough cement to connect to the original float they create when they are in their larvae stage of life. As they grow, the glands become larger and into an oval shape. When they grow, it allows them to create more amounts of the cement, which allows it to have a stronger hold towards the float or organism it's connected to. The cement has incredible bonding properties and is elastic and is a shock absorber due to its porous texture. This image here shows two figures. The one on the left shows a figure of a buoy barnacle in its early life stage. You can tell it's in its early life stage because the barnacles on the bottom of the figure aren't fully developed and are small and circular. You can also tell it is in its early life stage because the concrete canal is small and cannot secrete large amounts of concrete. The concrete that's already secreted out of the canal is just enough to connect to the float, which is labeled A, which all adds up to showing that it is a early life stage buoy barnacle. The one on the right shows a fully developed adult buoy barnacle. You can tell this because the glands at the bottom are fully developed and large, and the canal is large enough to secrete large amounts of concrete. The newly developed concrete passes through the old concrete due to its porous texture, and allows it to connect to other objects and have a stronger hold onto the objects they are already connected to, like the float that is shown in this image. Because the buoy barnacle has only been recently studied by researchers, much is not known about the capabilities of the cement it secretes. However, the uniqueness of the cement does allow it to have many possible applications in the real world. Due to its shock-absorbing abilities, it can be used in orthopedics and any medical application that requires a non-toxic elastic adhesive. And because of the elasticity of the cement, it can be used in cushioning vertebral discs in humans' backs. And the biodegradability makes it perfectly suitable as a three-dimensional scaffolding for tissue growth and wound healing like any other biofoams. This allows it to also be used in tissue and cell growth in any other situation other than wounds. Researchers also believe that the concrete could be used in any scenario that requires a water-resistant adhesive in any engineering form. But because it has only been recently studied, much is not known, and the practical parts of these beliefs have not been tested. There's still much to learn about the buoy barnacle and the cement, but in the future there could be many possibilities for applications for the cement due to its uniqueness and its capabilities. This concludes the end of my presentation on the buoy barnacle for Dr. Osborne's Tropical Marine Ecology class. Does anyone have any questions?